Okay guys, my video cut off there, so we're back for Unit 2, Lesson 8, Part 2, Solving Polynomial Inequalities. We just have one last question to look at. This is a application or word problem example, and we're going to look at some of these in Lesson 9 as well. So we have an object that's moving along the horizontal in a straight line according to the function. The distance is equal to negative time squared plus 16 times time, where d is the distance in meters and t is the time in seconds. When, okay, so a couple things I want to point out. When, so at what time, we're solving for t, when will the object be more than 50 meters away? Or in other words, when will distance be greater than 50? And distance is defined as negative t squared plus 16t. So in other words, we want to know when will negative t squared plus 16t be greater than 50. Now, there's two things we could do here. We could subtract 50 from both sides, bring that over here, but then we're left with this negative leading coefficient, and it's always best if we can, best if we can have a positive, but best case if we can have a leading coefficient of 1. So I'm actually going to rearrange this by adding t squared and subtracting 16t from both sides. And so when I do that over here, I add t squared and subtract 16t. These all cancel out, so 0, and then I'm going to rearrange this in descending order. T squared minus 16t plus 50. So in other words, we want to know when will this function t squared minus 16t plus 50 be less than 0, or in other words, when will 0 be greater than this function? So if this notation messes you up, just rewrite it, but t squared minus 16t plus 50, our alligator mouth doesn't change, so when will that be less than 0? Okay, these two things mean the same thing. So in order to do this, the only methods that we've looked at in this lesson, we either have to graph it or use our number line, but both of those methods require that we factor this. So let's start factoring. This is a simple trinomial where a is 1. However, my factors of 50, my numbers that multiply to 50, are 1 and 50, 2 and 25, and 5 and 10, and that's it. And none of these can be combined in a way that gives me a sum or difference of 16. Okay, so we could have 49 and 51, 23 and 27, 5 and 15, but we can't get to 16. So that tells me that I cannot factor. Okay, so therefore not factorable, but it does not mean that it is not solvable. So it doesn't mean that there's no solutions. So let's check if there even are solutions. Check for solutions. So remember a couple of things. When this happens, we have to use the quadratic formula, and the way we can check how many solutions from the quadratic formula is using the discriminant. So the discriminant is the part under the square root, b squared minus 4ac. I did review this back in one of our factoring lessons. So because it's under the square root, if this all works out to be a negative, then it's not possible. There are no solutions to this quadratic. If it works out to be 0, exactly 0, then there's only one solution, because the square root of 0 is just going to be 0. Whether we add 0 to something or subtract 0, we'll see more why that matters. And then if it works out to any number that is not negative or 0, anything greater than 0, then there's two solutions. So when we're looking at this, a is equal to 1, b is equal to negative 16, and c is equal to positive 50. So when we sub this in here, we have negative 16 squared minus 4 times 1 times 50. Negative 16, so negative times a negative is a positive, and 16 times 16 is 256. 4 times 1 is 4, times 50 is 200, and we have a negative there, minus 200. 256 minus 200 equals 56. So the discriminant is greater than 0, therefore there are two solutions. So that's good. So now the nice thing is if we've already checked for solutions by subbing into the discriminant, it actually makes our life a lot easier when we go to deal with the quadratic formula. So just draw a line here. Our quadratic formula is negative b plus or minus under the square root b squared minus 4ac divided by 2a, and this is going to be equal to, in this case, our values of t that result in this function having a function value of 0. So we start subbing in. B is already negative, so if we take the negative of a negative, we end up with a positive. So we end up with 16 plus or minus. Now here's the nice thing. We already checked the value of the discriminant, so we can just put the square root of 56 right here, and then we can divide by 2 times 1, which is just 2. So we could leave it just like that, but we can also clean this up. So the square root of 56, we can simplify that, or actually I guess expand it, but 56 is 4 times 14. So the square root of 56 is equal to the square root of 4 times the square root of 14. And you'll see kind of why we're doing that, because if we can split this number up into two numbers where one of them is a perfect square, then usually it allows us to clean things up and get rid of that denominator. So we've got the square root of 4, which is just 2. So we've got 16 plus or minus 2 root 14 divided by 2. That should be a 4, although it drew like a 9. And now 16 divided by 2 is 8. And 2 divided by 2 is 1, so those are gone, and then we just have our root 14. So ideally, our solutions do end up looking like this when we deal with the quadratic formula. It just makes our life a lot easier. So if we were going with, again, we can look at both methods. So let's say for method 2, we want to draw ourselves that number line, and we will have only 2 intercepts on it. And we don't know the value of them, but we can get them. But of course, 8 minus the square root of 14 is going to be less than 8 plus the square root of 14. And I did throw these into Desmos already. So 8 minus the square root of 14 is 4.3, and 8 plus the square root of 14 is 11.7. So we're really dealing with like a roughly 4.3 and roughly 11.7. And I'm just going to put those there because we'll need them to know what we're investigating on either side. Okay, so here we are trying to figure out what is the function value, is it positive or negative, for x values that are less than 4, and we can investigate anything we want. So why don't we investigate 0, because that makes our life super easy. And just to recall that the function that we are investigating is this one here, t squared minus 16t plus 50. Okay, so let's just write over here t squared minus 16t plus 50, just so that we can see what we're substituting into. So if we sub in 0, we get positive 50, so that means that anything less than 4, we have a positive function value. Now, hopefully, because this is a quadratic and we have these 2 intercepts and we know this is positive, hopefully we're already envisioning the what this graph would look like. But we could also go a little further, so we could say, okay, what's something between 4 and 11 that would be easy to substitute in? So I'm thinking 10, because if I sub 10 in, I've got 10 squared, which is 100, minus 16 times 10, which is 160, plus 50. 100 minus 160 is negative 60, plus 50 is still negative. And then on this end, I can sub in anything that I want, make my life easy. As long as it's greater than 11.7, I'll sub in 20. So I've got 20 squared, which is 400. I have 16 times 20, which is 320, so minus 320, and then plus 50. 400 minus 320 is positive 80, plus another 50, keeps it positive. And just to recall that we were interested in when will this function be less than 0? and not equal to 0. And the reason it's less than is because of the way I rearranged to get rid of that negative leading coefficient. It is very important that when you set up the question, you set it up so that you want to know when will the distance be greater than, more than 50. But when we rearrange, we end up with the function on this side and 0 on this side. So we are currently looking for when will the function be less than 0 for what, between what values of t, and that would be between here and here. So we would say, and again, this is a word problem, so we would want to put it into words. Therefore, the distance will be more, remembering what we were originally answering, than 50 meters on the interval. Now, again, different ways we can write it, but round bracket, because it didn't say greater than or equal to, right? Or in this case, less than or equal. So I'm just going to say 8 minus root 14, comma, 8 plus root 14, and then round bracket, okay? Or you could have used your inequality notation. It's up to you. And then really quickly, method 2, which is much quicker. We have our graph. We have our two intercepts. One of them is at 8 minus square root of 4, which we know is around 4.3, and one of them is at 8 plus the square root of 14, which is around 11.7, and we know that this function is a degree 2 even, so we know that the end behavior is going to be the same, and we know that it has a positive leading coefficient, so we know that it approaches positive infinity. So we know that it's somewhere up here and it comes down and it comes back up and it looks something like this, and we were interested in when that function was, again, less than 0, and that happens, as you can see, between these 2 points. Less than 0 is here to here, and so again, our interval, and just to show you for your inequality notation, you would say 8 minus the square root of 14, and your t is in the middle. So when t is greater than 8 minus the square root of 14, but less than 8 plus the square root of 14. And of course, we would put our whole statement, therefore the distance will be more, blah, blah, blah. Okay, that's it for lesson 8. There's your practice questions for, again, disregard this. This is for my in-person class for you guys, and we only have one lesson left of this unit. Yay!